Hi everyone, welcome to this multi-part series on sequence model for text data. I'll be essentially talking about text data, but sequence model can be applied to any type of data, for example, time series or DNA sequence or financial market data. Reason we need to understand the basics of sequence model is to better understand the nuances of large language models. So this is going to be a series of playlists here from my side, and we're going to focus on each of the major innovations in the field of sequence modeling. So in terms of the content of the playlist, we are going to typically follow the similar structure. Each of the playlist will be based on the concepts, the mathematical formulations, and the orientation equations, do's and don'ts, and some of the tips and best practices when we use those models. I'll be also using some of the use cases, for example, classification or text generation. We'll compare the RNN model versus the classical machine learning models. And then time to time, I'll be also showcasing the deployment aspects of the model using Hugging Face. Prerequisite for the course, a little bit of knowledge on the Python for data science, machine learning, deep learning, architecture, and the nuances of neural nets, familiarity with the text data handling, how we pre-process the text data. So these are the basic requirements in terms of your prior skills. Why we need sequence models? Because sequence data has temporal dependencies and meaning the data which is ordered by time, for example, stock prices data or data related to supply chain, they have temporal dependencies. That means the value now would be dependent on some of the values in the past. For example, if you look at this sentence, my flight got delayed, the overall emotion that is coming out of the sentence is negative, but this can only be possible if we read from left to right and sort of generate the context or understand the context from this sentence. So, a little bit about how sequence models evolved. Today, we are in 2023 and we have GPTs and OpenAI, GPT 3.5, 4, and 4.5, so on and so forth, Bloom and Llama. But it all started with recurrent neural nets around 1980s. And each of these milestones are, tremendous improvisation in succession. So I'll be creating the playlist for each one of them. For example, RNN or LSTM, encoder, decoder, transformers, and Bloom. This particular playlist is going to be focused on RNN and LSTMs to some extent. But LSTM, I will create a separate playlist altogether. So this is going to be a sequence model primer. So the agenda for the discussion, what are sequential data and what kind of applications we build using sequential data, some of the key challenges with the sequential models and why we need special machine learning models, and what kind of machine learning models are popularly used to, handle sequence data. So reason we should learn about the basics of sequence models to, appreciate the fine aspects of large language models, let's say GPT, Llama, and Bloom. And we need to have a strong foundation, technical foundation on sequence model in order to build modern day text-based applications using LLMs. So what are sequential data? Most of the sequential data today are uh, around text, images, and videos, and combination of all of these three. So sequence data is going to be ordered. That means the is arranged in a specific pattern or a sequence, most likely it would be in terms of date and time, and hence they have a temporal association that the value now is dependent on the value or some of the values in the past. And so the samples that we talk about here are going to have variable length. That means the sample now, or at this point, if it is having a length of 200, the next sample may not be 200. It could be lesser than 200 or could be more. So these are the primary characteristics of sequential data. Some examples, again, natural language data, for example, PDF and documents and review text, time series data, stock market and weather forecasting, genomic protein data like DNA and RNA sequence. Speech signals also fall under the category of sequential data. Some of the examples here, some more examples rather, the stock prices here associated with date and time, website traffic, the number of visitors coming to your website, again has association with date and time. Audio data is a very popular data series used in popular applications like Siri, Cortana, Amazon Echo, and here also the value at a particular time rather, is dependent on some of the values in the past. So more applications here using text data, machine translation, where you translate from one language to another. Again, a very popular application of sequence to sequence model. Sentiment analysis, where you're reading a paragraph or review text and trying to predict what's the overall sentiment from coming out from the text. Text generation is another example of your natural language processing. Speech recognition, as I mentioned, this is a very popular application using speech signals. And popular models that we use are transformer-based models nowadays, but initially, or rather a few years back, we were using the models like LSTM and GRUs to process the speech data. Some of the key challenges with sequence data, long-term dependencies. Let's take an example. If we look at the sentence, John went to the market, he bought some fruits. Here, the word he is actually John, and that's called co-reference resolution or long-term dependencies. In text, the long-term dependency can be longer than a few words that you see here. It could be more than 200 words, or it could be even longer than that. So that would be seriously difficult proposition when we deal with text data. Let's take a look at another example. She graduated in 2010, and after that, she started her business. So here, graduation and starting a business again have relations in terms of the time. Some more examples here. Nested structure. For example, if you eat too much, you get sick. That means eating too much has a causal effect in terms of getting sickness. Question answering is a very popular application again um, of text data. And here also the long-term dependencies play a significant role. Vanishing gradient, as you know, in neural nets, the vanishing gradient is a serious problem, and more so with the sequence data. The reason is we process the tokens or the word in succession. Essentially, what you're doing is you're multiplying the weights over and over again, and when we multiply the weights over and over again, the chances are the weights can become negligibly small, and hence we call that as vanishing gradient. And when we have vanishing gradient, that means the model has actually stopped learning. So these are serious, challenges with sequence data. Some more aspects of computational complexity. As you know, the sequence data is in series or in a sequence, very difficult to parallelize the operation, and that impacts the scalability of the model. Handling length of sequences which vary, that is another big challenge with the sequence data. Machine learning models that are popularly used to deal with the sequence data, primarily we start with recurrent neural nets. In this playlist, I'll be focusing on RNN and also LSTM. Subsequently, I'll also show you the transformer-based models like BERT and GPT-D, GPT-3, and exclusively we'll have a playlist for the BERT model. Next, I'll be showing you the technical architecture of recurrent neural nets and how each of the component or pieces of RNN actually work. Thank you.